So let's talk about predicting charge. Now, losing electrons, cations, it turns out that the number that goes next to this positive charge is equal to the number of electrons lost. Okay, so let's do a little practice here. Magnesium, we've seen before, make sure you know it's magnesium, not manganese, okay? And magnesium is in group 2A, also known as group 2, but we know it as representative element 2A. And that means that it has 2 valence electrons. So in order to get its octet, it simply needs to lose 2 electrons to go back to the noble gas configuration on the second energy level, right? And so it's going to, again, lose 2 electrons. And in doing so, it will become magnesium. It'll get a positive charge. And that number next to the positive is equal to the number of electrons lost. Well, we said it loses 2, so it'll be magnesium positive 2. What I'd like you to do now is I'd like you to figure out the charges of aluminum and francium. So pause the video and try it on your own. Okay, hopefully you tried it. Aluminum is in group 3A, okay, and so that means it has 3 valence electrons, so it has to lose 3 electrons, which means it becomes aluminum positive 3. Francium, on the other hand, is in group 1A. It's down here, right? And so it needs to lose 1 electron because it has 1 valence. Just needs to get rid of 1 electron to get back to that valence configuration for the noble gas. And so losing 1 electron means it becomes francium positive 1. This was a positive up here. All right. Now, when we name these guys, if we were to call this ion or this ion or this ion by name, we simply just take the name of the element, say magnesium, and we put the word ion after it. So magnesium ion. And then aluminum would just be aluminum ion. Simple as that. Okay? That's for cations in terms of just giving them names. Okay? Now, for anions, it's a little bit different. Okay? Technically, their charge is calculated the same way. Okay? So, in other words, chlorine, so right here, it's in group 7A. Here we go. So it has 7 valence electrons. To get to an octet, it simply needs to gain 1 electron. Okay, and so we figure out the charge the same way. It's chlorine, it's an anion, so we know it's going to be negative, and it's gaining 1 electron, so it's negative 1. But to name this, we name it slightly different. We take the beginning of its element name, so that would be chlor, and then we add an IDE ending. So it's chloride. Okay, so it's the beginning of the name plus IDE. Okay, so for instance, nitrogen is here. It is in group 5A, so it needs to gain 1, 2, 3 electrons to get to its octet, which means it becomes nitrogen minus 3 because it's negative because it gained electrons, and then it gained 3, so it's going to be negative 3, and we call it nitride. It's nitra, which is the beginning of nitrogen, and then we add the IDE ending, so it'll be nitride. Then phosphorus, why don't you go ahead and try that on your own, so pause the video and see if you get it right. Hopefully you paused it. So phosphorus is again 5A, so just like nitrogen, it needs to gain 3 electrons. Whoops. There we go. It needs to gain 3 electrons, which means that it will become phosphorus minus 3, and name-wise we would call it phosphide. Let's do one more. Oxygen, I know it's not listed here, but oxygen is here. It's in group 6A. It needs to gain 1, 2 electrons to get to its octet, so gain 2 electrons, which means it will become oxygen minus 2 as an ion, also known as oxide. Alright, so that's how we predict the charges of positive and negative ions. Keep in mind, we're not doing transition metals right now. Okay, we're just doing the representative elements. So groups 1A, 2A, 3A, 5A, 6A, 7A. Okay, and just as kind of a trick to help you out, this column here, which is not shown in either picture, it's kind of cut off, has carbon at the top. Whoops. Okay, so carbon would be there and carbon would be there. Carbon does not form ions based on what we know at this point. Okay, so no ions form there, which means that when you're looking at ions, any group to the left of carbon will form positive ions. So anything to the left of carbon forms positive ions, and any group to the right of carbon forms negative ions. Okay? So think of carbon as the dividing line. To the right, they form negative ions or anions. To the left, they form positive ions or cations. Now, there's one exception. Again, noble gases, right? They don't need to gain or lose, so therefore they don't form charges either. So don't worry about the charges of the carbon column elements or the noble gas column elements. Okay?